Okay, so here we go. Let's try our flipped classroom video for this topic. So today we're going to do linear relations. Linear relations, now some of us might remember from last year, linear relations means that we are finding out the relationship between two variables, generally one being x, the other one being y. And the relationship that we determine is based on an equation. So as it said over here, linear relations is just a way of relating two variables in one equation. Example, x and y. So an example is two variables in one equation could be something as simple as, let me get it, 2x plus 4y equals 9. That's a linear relationship. What it tells us the relationship between the x variable and the y variable. Another example could be y is equal to x plus 1. Another linear relation. It tells us how the y would change based on the change in x. So for every x value that we have, we add 1 and that'll give us the y value. Again, it tells us the relationship between two different variables. Another way of remembering linear relations is that there's only two variables involved. So two variables, two directions, and on our pair of axes, x and y axis. Linear relations are shown on a Cartesian plane. When the linear relations is drawn, it must form a straight line. So very important. It has to form a straight line. That's important. If the equation that you have, if it doesn't form a straight line, then it's not a linear relation. So examples of a non-linear relation could be something looking like that. It could be something looking like that. And there's a range of other relations which we will look into later. At this point, what we need to remember is that whatever graph we get, it needs to be a straight line. Okay, now let's go to some of the terms or some of the language that we need to know. And again, we might remember this from last year or the years before. Now, because we're in a linear relations, there's two variables, x and y. It has to deal with the x and y axis. Two main things that we will come across is the x-intercept and the y-intercept. Intercept, if you think, what does intercept mean? Intercept means that wherever something, anything that intersects, okay, so it crosses each other. So x-intercept means wherever your line crosses the x-axis. Now, if you have a look at the bottom graph that's going to come, so if you have a look at this graph, okay, so it says x-intercept where the graph cuts the x-axis. Wherever the graph cuts the x-axis, so this is our x-axis over here, our x-axis is over here. If you look at the red line, this is where the graph cuts the x-axis. So that would be our x-intercept. The y-intercept, on the other hand, I should change the color, I think, of the y-intercept. Let's see if I can do that. Oh, yeah, there you go. The y-intercept, likewise, would be wherever the graph cuts the y-axis. Okay, and again, if you have a look at our graph over here at the bottom, the red line cuts the y-axis at this point. So if you have a look at these 2 points, the x-intercept, at the x-intercept, if you look at the coordinates of the x-intercept, it's 2, 0. If you look at the coordinates of the y-intercept, it's 0, 4. Okay, and that tells us that wherever the y-intercept is, which is on the y-axis on point 4, the x-coordinate is 0. And that is again shown on our table. So if you have a look at if you have a look at our table, okay, our y-intercept, this is where our y-intercept is. Our x-coordinate over there is 0. Likewise, if you have a look at our x-intercept, now this is where the x-intercept is, over there. Our y-coordinate, which is over here, is 0. So that is another important point that you need to remember. Wherever the x-coordinate, x-intercept is, our y-coordinate would be 0. Wherever the y-intercept is, the x-coordinate needs to be 0. So there are a few ways of showing linear relationship, and there are a few methods on how we can draw the straight line. So what we need to remember so far, what we need to remember is linear relationship gives us a straight line. Okay, and another thing that you need to remember is when anything is linear, then the change is consistent. So if there's a change, if in the y values there's a change of 1, for example, then in the x value, again, it'll have a consistent change. It could be a change of 1, it could be a change of 2, it could be an increment of 1, an increment of 5, but it would be very consistent. So the increments that you have in your x values and the increments that you'll have in your y values would be consistent. Okay, so moving on. Right, there are a few ways to draw a linear graph. The very basic, simplest one is when you create a table of values. Now, a table of values look like this. You have a table, and you have your x values, which normally ranges from a negative to a positive value. So you could go from -2 to +2. And then you find the y values by substituting each of these x values into the equation that's been given to you. Okay, so let's have a look at this example. So you've been given this task using our x values from -3 to 3. So as we learned last week, this sign means x is greater than or equal to -3 and x is less than or equal to 3. Okay, so that means our values are ranging from -3 right up to 3, and it includes our -3 and 3 values. So what we need to do is to construct a table of values and plot a graph for these linear relations. The relationship is given by this equation. Okay, so what you would do is you would take the values of -3 right up to 3. So -3, -2, -1, 0, 1, 2, and 3. And you construct a table of values. Now, how do we get these y values? We get these y values by taking each of these individual x values and substituting it in the equation that's given. So I'll do a couple for you. Okay, so let's do one. So for x is equal to 3, so for x equals -3, y would be equal to, you substitute it into this equation. So wherever there's x over here, you substitute that by -3 plus 2. That gives us 6 plus 2, and that is equal to 8. So if you see that on our table, there's an 8. Let's try another one. I'm going to try for x equals 0. Then y would be equal to -2x plus 2. So in place of x, we substitute 0. And that gives us -2 times 0 is 0, plus 2 is 2. And if you look for y equals 0, we've got, for x equals 0, sorry, we've got y equals 2. And likewise, that's what you would do to find these y values for all of these x values. So, excuse me. Once you get that, once you get you've got your table of values, then you plot them. And obviously, now some of us might have forgotten plotting, but I'm just going to show you very quickly how we plot this, just in case some of us have forgotten. Okay, so if you have a look, our point -3, 8, which means that on our y-axis we go to -3, on our x-axis we go up to 8. So this is our first point over there. That is -3, 8. Then we do that to the second point, which is -2 and y6. So we go on to our axis, that's -2, go up to the y value of 6, and you plot that point as -2, 6. And that's how each of these points are plotted. Once you have got all of those points, you grab a ruler and rule a line, straight line, joining all of those points. Now, what we need to remember also is once that's done, always write the equation of the line. So if we go back, the equation of the line was y equals -2x plus 2. You've drawn your line and you write down somewhere there y equals -2x plus 2. And that would be your complete graph. Now that is one method. That's the first method. And that's what we're going to practice in class tomorrow, on Tuesday. That's what we'll practice in class on Tuesday. We'll learn other methods as we go along. Okay, so now the next thing is if you can print this worksheet, bring it in on Tuesday. Otherwise, open that up and then we'll practice that in class. Okay, now another thing that's important is you can also use the equation of the line to see if it falls on a line graph or not. And the easy thing to do is just substitute. So looking at that example over there, let's see. So what that means is when x is equal to -2, is y equal to 4 in that equation? Okay, so let's just see whether that's true or not. Okay, so y is 4, and that is equal to -x plus 2. Our x value is -2. Negative of -2 means negative of -2 there, plus 2, which means it's 2 plus 2, and that is equal to 4. So if they equal, this shows, therefore, -2, 4 lies on the line y equals -x plus 2. You need to make sure that you state that. Very important that you state that. All right. So here we go. Let's try this, and let's try some of these questions from this page as well. So we'll do our worksheet first, and then we'll move on to some of these questions.